All right, let's talk about one of the most important, but maybe one of the most misunderstood parts of any vehicle, the differential gear ratio. It's really the unsung hero that decides a vehicle's whole personality, balancing that raw, gut-wrenching power against smooth, high-speed efficiency. To get our heads around this, just think about this question for a second. How is it that a huge, heavy truck can pull thousands of pounds like it's nothing, but a sleek sports car, which is obviously built for speed, would completely struggle with that same exact load? Well, the answer to that puzzle is all about the engineering trade-off that's managed by the differential gear ratio. So here's how we're going to break it down. We'll start with the core concept. Then we'll get into decoding the numbers themselves. After that, we'll explore the huge trade-off between torque and speed, check out some real-world examples, and then finally, we'll see how it all fits into the bigger picture. Okay, first things first, let's build a solid foundation here. What are we really talking about when we use the term differential gear ratio? So what you're looking at here is the heart of the whole system. The differential. It's this incredible piece of mechanical engineering that grabs the power from the engine, which comes down the driveshaft, and then sends it out to the wheels. But it's even smarter than that, because it also lets the wheels spin at different speeds, which you absolutely need when you're making a turn. So here's the key takeaway. The gear ratio, it's just a number, and that number defines how many times the driveshaft has to spin around to make the wheels turn exactly one time. Think of it like a multiplier that governs how the power gets transferred. And that brings us to the numbers themselves. When you hear things like 3.73 to 1 or 4.10 to 1. Now, this is where a lot of people get kind of tripped up, but honestly, the logic behind it is really straightforward. Let's just break it down. The ratio itself comes from some really simple division. See, inside that differential, you've got a small gear, the pinion gear, that's spun by the drive shaft, and it meshes with this big gear, the ring gear that's hooked up to the axles. All you do is divide the number of teeth on that big ring gear by the number of teeth on the small pinion gear. That's it. That's where the number comes from. So let's take a really common ratio you'd find in a truck, something like 4.10 to 1. What does that number actually physically mean? It's simple. It means that for your wheels to make one single, complete revolution, that drive shaft has to spin 4.1 times. This creates a huge mechanical advantage. Essentially, the engine's work is getting multiplied before it even gets to the tires. And that mechanical advantage, well, that brings us right to the central conflict of automotive engineering. The thing is, you just can't have maximum pulling power and maximum top speed at the same time. You have to pick one. And that choice is the great trade-off. Here it is in a nutshell. A numerically higher ratio, like that 4.10 we just talked about, is all about multiplying torque. That gives you incredible acceleration and pulling power. On the flip side, a numerically lower ratio, say a 308, prioritizes high-speed cruising and efficiency. Let's see how that looks when we compare them side by side. And this table just lays it all out perfectly, doesn't it? With a high 4.10 ratio, you get amazing off-the-line acceleration, and you can tow just about anything. But there's a cost. Your top speed is lower, and your fuel economy suffers because the engine is just spinning faster at any given speed. With the low 3.08 ratio, it's the exact opposite story. Slower acceleration, can't pull as much weight, but you get a higher top speed and much better fuel economy from those lower engine RPMs on the highway. Okay, so with this trade-off in mind, how do engineers actually apply this stuff to the vehicles we drive every single day? Well, it's all about matching the gear to the job the vehicle is designed to do. These numerically high ratios, people often call them short gears, they're built for work. They give you that raw torque you need for quick acceleration, for towing heavy loads, and for that low-speed control you need when you're off-roading. It's exactly why you find ratios like 3.73 or 4.10 in pickup trucks, Jeeps, and other 4x4s. Now, on the other end of the spectrum, you've got the numerically low ratios. We call these tall gears. These are all about efficiency and easy cruising. They let the engine loaf along at a much lower, quieter RPM at highway speeds. That saves fuel, and it allows for a higher potential top speed. This is the setup you're going to find in most family sedans and cars designed for commuting. Right. It's really important to understand that the differential doesn't work in a vacuum. Its effect is just one part of a much larger interconnected system. And frankly, not understanding this is where some very common myths come from. The final performance you actually feel when you're driving is a combination of everything. The differential ratio, sure, but also the gears inside your transmission and even the size of your tires. For example, if you put bigger tires on a truck, you're effectively lowering its gear ratio, which can actually hurt its ability to tow. It's all one big system. So, this brings us to our first myth, and believe me, it is a big one. A lot of people think that a higher number, like a 4.56, must mean the car is faster overall. And that is absolutely 100% false. A higher numerical ratio gives you faster acceleration. It gets you up to speed quicker. But it will almost always give you a lower overall top speed because the engine just runs out of RPMs much, much sooner. Okay, here's the second common mistake. Thinking that swapping out your differential gears is just a performance mod you do to make your car accelerate faster, and that's it. And that's also false. As we've seen, changing this one part has a ripple effect across the entire vehicle. It is going to directly impact your fuel economy, how noisy your engine is on the freeway, and how much weight your vehicle can actually pull. It fundamentally changes the entire character of the vehicle. So in the end, maybe the best way to think about it is like this. The differential gear ratio is the silent controller. It's that crucial design choice that decides whether a vehicle is going to pull hard off the line or cruise efficiently down the highway, or if it's going to sacrifice one of those things to be better at the other. It really is the ultimate expression of that engineering trade-off.